note-taking with vocabulary right in front of them. Brand new lesson today. The way I'm going to start this lesson off is with a small discussion about a thug from Pomona. There's a thug from Pomona. Don't you just love thugs? They take advantage of their grandmas and grandpas, and they take advantage of their mom and dads. They don't do anything with their life. They steal. They eat all the food in the refrigerator, and they prey on people who are weaker than them. Don't you love thugs? Anyway, this thug is from Pomona. Let me show you the situation with this thug as it relates to functions. What the heck is a function? Reyes asked earlier. Yeah. Check this. Look at this thug. Look at the situation with this thug. Look at the situation. You don't have to write this down. Just pay attention. So this thug is on the corner of, let's see, Gary and 2nd Street. There's a Chase Bank there on Gary and 2nd. After stealing an old lady's purse. Oh, man. That gets me angry just thinking about it. After stealing an old lady's purse, a thug ran away from a cop at a rate of 4 feet per second. Okay? We're going to get into the cop right now, chasing him. But right now, the cop sees the guy running away from the old lady. But just right now, just the thug, he took the old lady's purse on 2nd and Gary. He starts running away from her at a rate of 4 feet per second. So let me see. Let me graph this puppy. If I don't write this, right now you're just paying attention. If I let the horizontal axis, that means the x-axis, be seconds. Sure. And I let the vertical axis be feet. What I'm going to do is I'm going to graph points that describe the thug running away from the old lady. Okay? Just a minute. All right. Phone's away. Remember, stamp, even if you're productive. If you have the phone out while I'm talking, you're going to lose the stamp. Have the phones out just for my lecture. You'll get to look at your phones after. I'm not going to be that long. Here we go. All right, so let's see. The thug. He's running away from the old lady at a rate of 4 feet per second. Okay, let's try to plot this puppy. So at 1 second, so if you look at, remember, this means seconds. You're just paying attention. You're not writing anything down yet. This means seconds. This means feet. So at 1 second, how far is he away from the old lady? 4 feet. Look at 1 second, 4 feet. Okay. Okay. 2 seconds. How far is he away? 8 feet. So far, so good. Thug's running away. 3 seconds, 12. So it'll be about right up here. And even in between the seconds, like let's say half a second, there it is, he's 4 feet. 1.5 seconds, 2 seconds, 2.5 seconds, 3 seconds. Okay, so this is going to keep going. This is going to keep going up. Look, I put the arrow here. He's still running away. Look at this right here at the bottom. There's a cop, Pomona PD. The cop, after a 4-second delay, so let's see, 1 1,000, 2 1,000, 3 1,000, 4 1,000, begins to chase the thug. At what time will the cop catch up with the thug if he's running at a speed of 5 feet per second? So what we're going to do is, before we even solve this, right now I want to talk about the thug first before we get into the cop. So there's something going on here. There's a pairing going on. There's a pairing going on between seconds and feet. Look at seconds and feet. Seconds, feet. That pairing is called, in math, a relation. A relation, which is the first word on your note guide. So get that note guide out, and let's define that first word, a relation. Does anybody not have the note guide in front of them? Here you go. Mendez? So the first word's relation. Let's go ahead and define this. A relation is, here we go. With the thug, there was a pairing between seconds. So go to right underneath this, put thug example. The thug example, there's a pairing between seconds and feet. And put parentheses. There's a pairing. Seconds and feet. For every second, there's some type of feet. There's some type of amount of feet that he ran away from the old lady. Okay, that's a relation. Now, what about a function? Next word. A function is a very special kind of relation. A relation that pairs each input with, now I'm going to have you put this in all caps now, with exactly one output. A relation that pairs each input with exactly one output. Okay, write that down. Range. Last two words, going to write that. The domain of a function is a set of all possible input values, and the range of a function is a set of all possible output values. And I got a picture of a machine there that's we're going to talk about what a function is with a machine. So I'm going to copy that down. Okay, so we're not going to define those other words yet. We're going to define those on Monday. Flip the page on the bottom. Go and turn the page over at the bottom. You'll see the machine that's on my screen. Look at the machine at the lower part of your paper on the back. It's a function machine. Okay? Watch this. Imagine a machine where the inputs go into the machine, something happens to the inputs, and it spits out an output. So on your machine right there, go ahead and mark up your paper, and go ahead and write inputs are always, put an arrow at your X, look at there in blue on my screen, and the outputs are always your Y. Put arrows like that for me. So something goes in the machine, that's your input, obviously the word in, and the machine spits out an output, the word out. In, out. In, something happens to input, spits an output out. So the number for the input here was -2. We put a -2 in here. We take 3 times -2, that x, this is the x value, 3 times -2 becomes -6, so y equals -6. Go ahead and put another arrow coming in. Let's put, how about a -5? What if we had a -5 input? Put that on your picture. If we put a -5 into the machine, what will the machine spit out? -15. Put an out arrow, -15. Notice that. So we put the input is your x value, so 3 times -5. Y then equals whatever happens here. That's your output, -15. It's a machine. Let's put in +4. Input, 3 times 4. The output, 12. Input, output. So far, so good. Now the next part, just let me talk. Don't write this down. What if I said, you know what, the function is not y equals 3x. What if I just said the function is your age? How about just age? And my inputs are not going to be numbers, but my inputs are going to be people in this classroom. So don't write this down. Watch. So age will be the function machine. The inputs will be people in here. So let's see, Miss Rocha, I'm gonna put you in the machine. I'm putting the Rocha in the machine. The age is the machine. Rocha, what's your age? Quintero, how old are you? I'm putting Quintero in the machine. The machine spits out the age. So think of the machine not necessarily with numbers. The machine does something to the input and it spits something out. Mungia, I'm gonna put myself in this machine. Does anybody know how old I am? Close. Extra stamps for this guy.
44. 47. 43.
Oh yeah, I heard it. What? Got it. 42. 42. He's all proud of it and happy. I insulted you. Never mind. Mungia, age 42. So the age here is the machine, as opposed to just taking an X value and multiplying it by a number. Look at this funny video. Watch. Check this out.
Is it really going to be funny or
It really is, Sanchez. It really is. Watch this. Give it a chance. Give it a chance.